I'm going to test some components, mainly capacitors, on several different testers. One is the DE-5000 LCR meter. Another is one of the Chinese AT-Mega transistor component testers. The other is a classic Eico 950B capacitance resistance bridge that has been fully restored. And then a Bob Parker blue ESR meter. The first capacitor we'll test is a Sprague 250 microfarad 75 volt electrolytic capacitor that was salvaged out of some electronics that industrial electronics I got for my work. The Sprague capacitor is in the Eico 950B, and it's coming in at just under 250 microfarads, maybe 240, 245, something like that. Now I'll test for leakage at the 75 volt DC rated working voltage. So we'll turn this selector knob to electrolytic test, which is sensitive to 2 milliamps of leakage. And as you can see, the eye tube is currently open. We'll turn the voltage to 75, go back up to the eye tube. It takes a little bit to charge since it's such a large capacity, 250 microfarads, but you can see it opening right now, and it will continue to open. So that indicates that this capacitor has no leakage at 75 volts DC, which essentially means that it is good in terms of the Eico 950B testing capacity. After I run a voltage test on the Eico, or anytime I'm looking to discharge electrolytic capacitors, I always short it to drain the capacitor. And here I'm using a 100 ohm 10 watt resistor to discharge the capacitor, and typically 5 to 10 seconds will discharge it. I'll test the capacitor to make sure it is discharged. Showing about 7/10 of a volt, so I really don't want to test it with the DE-5000 or the digital Chinese tester here until it's totally discharged, although half a volt is probably fine. I'll hook the discharger up to it for just a little bit longer. Now the capacitor hooked up to the Chinese LCR meter here, and you can see that it's reading 240 microfarads and an ESR of 0.24 ohms. And the Eico 950B I was estimating was 245 microfarads, so they're pretty close, and I believe that was 0.24 ohms of ESR. So 0.22. So we'll test it on the DE-5000 next. I have the Sprague hooked up to the DE-5000 now, and you can see it's reading 236 microfarads and 0.2 ohms of ESR, equivalent series resistance. So that's quite close to the Chinese AT-Mega unit, and in terms of capacitance, very close to the Eico 950B. I happen to have a data sheet here, which is for an equivalent Sprague unit, and we can see that at the 75 volt range it should have a dissipation factor of 30% or less, and the capacitance tolerance is plus 75 minus 10, so we're certainly in that range. If we switch the DE-5000 to the dissipation factor, let's see, I just had it there. You can see it's 0.042, which is also read as 4.2%. So it certainly appears to be a good capacitor. And let's see here, the phase angle is minus 87.4. So if the phase angle is less than 0, that tells you it's a capacitive reactance. And the closer to 90 it is the closer it is to an ideal capacitor. But you probably never achieve 90 because there's always a reactive or a resistive component to inductances and capacitances. So far, these three units agree fairly closely on the capacitance, and these two units on the ESR. I'll try it on the blue ESR meter next. Okay, the Bob Parker blue ESR meter is reading 0.15, so that's a little lower than the AT Mega or the DE-5000 unit. I'm not sure what frequency this tests the capacitor at. I had the DE-5000 unit at 120 Hertz. So what all of these units are telling me is that this is a good capacitor, and the capacitance is a little lower than 250, but it's certainly within spec. So I would say this is a good capacitor, and I'd feel comfortable using it, reusing it in any non-critical application. Next, we will test a new Nichicon 680 microfarad 200 volt capacitor, electrolytic. I have the capacitor hooked up to the Eico 950B, and it's very important that you observe the polarity of the capacitor. Make sure the negative lead of the capacitor is hooked up to the negative lead of the chassis, and positive to positive. I have it on the expanded range, and it is about, I would say, greater than 750. It almost looks about 800 microfarads on this unit here. I'll test the leakage next. Okay, I have the selector switch set up for electrolytic leakage. This is a 200 working volt rated capacitor. So watch the magic eye, and you can see that it's currently open. I'll turn up the voltage to 200, and you can see the eye temporarily closed as the capacitor is charging, and it should reopen. Now a 680 microfarad capacitor is going to take a little bit to charge here. Okay, we can see the eye tube is opening back up, so the capacitor is not leaking, or if it is, it's less than 2 milliamps of leakage at 200 volts. So the Eico has tested it as good from a leakage perspective, although it did read a bit high on capacitance, but once again on this expanded range here, the accuracy I don't think is the best. Once again, I'll discharge the capacitor with my power resistor jumper leads here. Okay, the capacitor is now discharged and hooked up to the AT Mega unit. It's showing 706 microfarads with an ESR of 0.15. So the Eico 950B, looking somewhere around 800, wasn't that far off. We'll try the DE-5000 next. The DE-5000 is testing this at 682 microfarads with an ESR of 0 and a dissipation factor of 0.043 at 120 Hertz test frequency. Now the data sheet shows the dissipation factor, which they call the tangent of loss angle theta, for a 200 volt capacitor, let's see, to be 0.12 or less. And at 0.043, that certainly passes, so that tests good on the DE-5000. Same capacitor on the Bob Parker blue ESR meter, showing an ESR of about 0.05 or 0.06. So I believe the AT Mega unit was 0.12 and the DE-5000 was 0, and this is about 0.06. So they're all low ESR. But appears to be a good capacitor. It's a new capacitor, and you can see what the variation is between these different test instruments. Here is a new small 4.7 microfarad 350 volt Nichicon electrolytic. I'm going to test it on the Eico, on the DE-5000, and on the AT-Mega. I'm not going to do a voltage leakage test though on the Eico. We'll just test for capacitance on the Eico. Okay, on the Eico, I did my best to adjust this for maximum eye opening. It's right about 4.5 microfarad. So we'll try this on the other units and see what we get. Okay, the DE-5000 is testing this capacitor at 4.88 microfarads, whereas the Eico is 4.5. And the spec sheet says that the dissipation factor should be 0.25 or less at 120 Hertz. We have 0.034, so this certainly tests good. And for the heck of it, we'll check the ESR. 9.2 ohms, 4.8 microfarads, 9.2 ohms. We'll remember that when we go to the AT-Mega. Okay, let's see here. 5 microfarads. For some reason the camera's not picking it up very well. And 3.6 ohms of ESR. So the ESR quite a bit lower on this unit than on the DE-5000. 3.6 ohms. I believe it was 9.2 ohms on the DE-5000. We'll check the blue ESR meter and see what it reads. Okay, the blue ESR meter is reading 4.2 ohms on this capacitor. And let's see, for a 4.7 microfarad capacitor, 350 volts, it's saying if the ESR is roughly below about 80, it should be good. So that's a good capacitor. Okay, we're switching to resistors. Now I'm going to test a resistor. First one is on the AT-Mega, and I can't tell if it's picking this up or not, but it's reading it at 1005 ohms. Same resistor is reading 1000 ohms on the DE-5000. So 1005 on the AT-Mega, 1000 ohms on the DE-5000. I popped on the Eico 950B for the heck of it, and it's reading about 1050 ohms, which is actually 5%. It's a 1000 ohm resistor. 10% would be 1100, 5% would be 1050. So this is within 5% accuracy, which is pretty good for 1950s technology. Analog, looking at an eye tube. Not bad. Now here's a little bit of a shocker. That same resistor that the super accurate DE-5000 read as 1000 ohms, here's an ancient Micronta Radio Shack benchtop multimeter, and look what it's reading. I bought this off eBay, and it was out of calibration. I calibrated it myself, and it's virtually reading dead on within what, 1/10 of 1% or so. Not bad. BK Precision 2709B reading the same resistor at 998 ohms. So if we say that the DE-5000 is accurate, then this is a couple of ohms off, which isn't bad at all, percentage-wise. Here is a Cornell Dubilier Beaver model capacitor, 60 microfarads, 150 working volts, DC. The Beaver model. I wonder if they had the woodchuck and muskrat model too. And before I hook this up to any of these modern solid-state testers, I want to make sure there was no voltage in it, which there isn't. Okay, let's see what the AT Mega tests this at. 75 microfarads, 0.29 ESR. A little high. What is that? About a little over 20% high. But for an old capacitor, that's probably in the ballpark. Alright, the DE-5000 is testing it at 70 microfarads, 120 hertz. Let's see what it's showing for an ESR here. .3 ohms. The Bob Parker Blue ESR meter is showing this Beaver model capacitor at 0.19 ohms of ESR. The Eico 950B is testing this at about 77-78 microfarads. Let's see in terms of leakage. It's 150 working volts, so we'll change this to electrolytic test. And I think you can see the eye tube is open right now. We'll crank that up to 150 volts. And wait a little bit here because it is 60 microfarads. Takes a little bit to charge. And I can see the eye tube starting to open slowly. But if it's open at all, that means that the leakage is less than 2 milliamps. And if I continue to wait, it'll open even farther, which it is. So it appears to have less than 2 milliamps of leakage at 150 volts. So it appears to be good on this tester, and in terms of the ESR and that on the other testers, it appears good too. So even though it's an old one, I don't think I'd put this in anything new or critical, but some uncritical application potentially you could put it in there. Although when you're using a capacitor that old, it's always a bit of a gamble to use them. And on these Eico 950Bs, when you run a leakage test at high voltage, it's always smart to turn the voltage pot down slowly because it helps to bleed the voltage out of the capacitor. But even if you do that, you can have 2, 3, 4, 5 volts left in the capacitor, and it makes sense to use one of these here, some kind of a jumper, to short out the capacitor and and bleed any residual voltage out of it, so you don't get shocked or you don't damage any other equipment. I'm going to test a couple of inductors or coils on the AT Mega unit and on the DE-5000. See how they compare. Alright, let's see. I've got this coil hooked up to the AT Mega unit, and it is showing 0.08 millihenries of inductance. 0.08 millihenries. The DE-5000 is showing 96.8 microhenries, which is 0.097 millihenries. So fairly close, a little over 10% higher of the AT Mega. And let's see the check the phase angle here. Put that back to LS and so you see the phase angle is a positive 81 degrees. It's greater than 0, so that means it's an inductance. The closer it is to 90, the closer it is to a perfect reactance, whether inductive or capacitive reactance. So it's a little less than 90, which means there's resistive losses in this inductor. Alright, testing the next little inductor here in the AT Mega unit, coming up as 0.11 millihenries. And if you get one of these AT Mega units, make yourself up some of these test leads here with these little micro grabbers. It really makes it handy so you don't have to put the component in these little sockets every time. So 0.11 millihenries. We'll try it on the DE-5000. Alright, on the DE-5000 we're reading 119 microhenries and we were 0.11 millihenries on the other ones. So if you do the conversion, those are basically the same. And for the heck of it, let's see what the phase angle is here. .55 degrees. So that's quite a ways from positive 90 degrees, which tells me there's quite a bit of a resistive component to that calculation. Here's some bonus footage. This is a 0.002 of an ohm resistor, a 2 milliohm resistor, 1% accuracy. Let's see what the DE-5000 says. There it is in the leads, 2 milliohm. How's that for precision? Well, I hope you enjoyed this comparison of these various testers. If you have any questions or you'd like to see any specific tests of any of these units, please let me know and I'd be happy to accommodate you. Thanks for watching.